But the biggest issue, and like remember these are modeled on the human brain, right? So you're like, well, maybe if we just throw more neural network at our neural network problem, it'll be good. The problem is the error actually gets worse the more complicated these go, right? So if we have one hidden layer, the error is like down here, but as we increase, the error gets worse and worse and worse, right? And so what we're not learning anything, we're just becoming more and more random or something, right? So this has led to the, well, by the end of the 90s, like neural networks was kind of like on the wane, and so more sophisticated stuff came out. Support vector machines, which I had the picture of before, you know, they were a little more rigorous in their like methodological or probably, you know, like technical or theoretical backing. Lots less parameters to tune. I mean, like if you saw, I skipped through it really fast, but there was a lot of W's on there. And those are all things you have to tune. The size of the network, all your biases, I kind of skipped over those, but anyway, there's a bunch of stuff to tune in neural networks. You know, support vector machines have like very little stuff. And now again, like with the rise of the internet, we have, you know, these huge chunks or these huge corpuses of data, and we can throw much simpler algorithms or systems at them, and they will tend to do pretty good. And then they're much, you know, they're quicker and they don't require any tuning, anything like that. Things like naive Bayesian, just like, you know, like simple, you know, probabilistic decision trees and things like that. So, you know, they were working on it, but, you know, it slowed way down. And I think, you know, if I had gone to school a little later, I probably wouldn't have heard of neural networks. So anyway, I'm going to turn this over to Rajesh because he promised. Thank you.
Does everyone take a break?
I was thinking too fast. Oh, sorry.
Anyone go grab beer or please? I can go.
Yes.
Okay, so thanks, Anthony. So, I mean, the moral of the story is like, you know, I learned all of my series through movies. So, I don't know if you guys,
What movies are you watching?
there's a movie called Pi. That says, you know, the whole universe is made of numbers, and there's a pattern in the numbers, right? So that's all we want to do. So the main goal of machine learning is always take whatever you have and convert it into numbers, right? You can do like different techniques, do a lot of transformations, apply math, but at the end of the day, the machine learning works only if you have numbers. So, you know, then, you know, all these other techniques and all that stuff. So Anthony pointed out the problems with neural networks. So what happened in 2007 was there was this major breakthrough. Now, I saw some people who have like PhDs in computer science and stuff, so I just got the papers that talks about why there was